Hello everyone, this is the fourth lesson on Arduino C, and today we're going to start with functions. So let's make this header 2. You'll often find yourself using the same code in multiple locations. Doing large chunks of these is a hassle. However, functions make these a lot easier. You can encapsulate your C code into a function and then use it as many times as you want. How we use it is that there's a structure. First we write the data type and then the function name, parentheses, and then the curly brackets. Inside here we can write the code statements. So this is a basic data structure, and then the data type can be anything such as strings or characters, integers, or booleans. And then if you want a function that does not return any data values to the calling program, you use the void data type for the function definition. So then it would be void my function, function name here, and then the code statements here. So let's do an example. So loop and setup are both using void, but these two are defined by Arduino as the setup that only runs once and then the loop that runs repeatedly. If we want to make our own, we can do void, let's say my function, and then inside we can print something. Let's say serial.println. This is my function. Then we can run it. Let's define the serial begin, and then print a blank line, run my function. Okay, so now we should, forgot the semicolon. Alright, now if we come into the serial monitor, we will see this is my function. So as you can see, if we want the function to run, if it's not set up or loop, then we need to call it again like this inside another function. So let's write that. Oh yeah, one other thing, we defined our function outside of the setup and loop. That's how you can make a global function. Make sure you define your function outside of the setup and loop functions in your Arduino code sketch. If you define a function inside another function, the inner function becomes a local function, and you cannot use it outside the outer function. To use a function you defined in your sketch, just reference it by the function name you assigned, followed by parentheses. So like this, we defined it outside of the setup function. If we were to define this inside of the setup function like this, then it would be what's called a local function and can no longer be called outside of the void setup. So if we wanted to run my function inside of the loop, we do this, this first. If we run it like this, then it would say that we could not find my function because this is a local variable or local function that can only be called in the outer function, which is setup. Alright, let's move this back out. Alright. And then let's talk about returning a function. To return a value from the function back to the main program, you end the function with a return statement. The value can either be a constant numeric or string value, or a variable that contains a numeric or string value. However, in either case, the data type of the returned value must match the data type that you use to define the function. So for example, in this function, if we want to return something, we have to match it to the data type here. Let's say if we make it an integer, we can do integer return. We can return a integer, let's say 1, 2, 3, and then we can print it. Serial.println my function. So like this, it would first run the my function and then return the 1, 2, 3 at the very end, and then it would print 1, 2, 3. But before that, it would print this is my function. So let's see. Alright, so it says this is my function. And then 298. 298. Huh, that's interesting. Oh, that's because we need to make this not, this is an integer, not a string. So now it should be 1, 2, 3. Yeah. Alright, sorry about that. Next, let's talk about passing values to a function. Returning gives a result back from a function. Now we can start with an initialized value into the function. You will most likely want to pass values into the function. In the main program code, you specify the values passed to a function in what are called arguments, specific inside the function parentheses of the C's. This should be a comma. So for example, we can have an integer, let's say x. Now this is a value that we can pass into the function. So let's say if we enter in 3 here, let's say my function doubles whatever is entered in. So we can do x equals x times 3 or times 2. So it should return a 6. Let's see. So now it returns 6 because 3 times 2 is 6. And we got 3 from this, which turns into integer x, and then x times 2 is 3. So this is how we can pass a value into a function. and then to retrieve the arguments passed to a function, the function definition must declare what are called parameters. You do that in the main function declaration line. So for example, integer is a parameter that states the input can only be an integer type data type. Okay, so that is passing values. Then let's talk about the scope. One thing that causes problems for beginning sketch writers is the scope of a variable. The scope is where the variable can be referenced within the sketch. Variables defined in function can have a different scope than regular variables. That is, they can be hidden from the rest of the sketch. Functions use two types of variables: global variables and local variables. One can write global variables before the setup loop, while local variables are declared in the function code itself, separate from the rest of the sketch code. What's interesting is that a local variable can override a global variable, although this is a terrible practice. Alright, so for example, we can define an integer y equals 4 outside of the sketch, and then we can return x multiplied, or x plus y. So 3 plus 4 equals 7, like this. So now it's 7. And then if we wanted, we can turn this into y as well. And then we can do return y. Now do you think this would return a 4 or a 3? And here it says the local variable can override a global variable. So that means the 3 overrides the 4, and we can return a 3. So yeah. And then next, let's turn this back into the x. And then let's try to call x here again, or let's say here. Let's print x. Since x is defined here, this is a local variable, and it cannot be called outside of the function. So if we want to call it here, then it would not work like this. Again, this is a local variable, so it cannot be called outside of its function. Alright, next let's talk about a very important thing that we can do through functions, which is called recursion. Recursion is when the function calls itself to reach an answer. Usually, a recursion function has a base value that it eventually iterates down to. Many advanced algorithms use recursion to reduce a complex equation down one level repeatedly until they get to the level defined by the base value. You can also call other functions from inside a function. So, okay, we no longer need my function. Let's use factorials as an example. So we write factorials as a number and then an exclamation mark. How it works is that, let's open a drawing pad. So how it works, for example, let's do factorial of 3. 3 factorial would equal 3 times 2 times 1. So it multiplies every whole number lower than itself until it reaches 1. So how can we write this using code? Now we can use recursion for this. For example, we can define an integer function called factorial with an input of integer x, and then we can do if x is less or equal to 1, then we can return 1. Otherwise, we can return x times a factorial of x minus 1. So if we start with, let's say 3, then the 3 times 2 times 1 should equal 6. Well, this should equal 6. Let's see if we did it right. Oh, okay, I spelled this wrong. Factorial, factorial. Alright. Man, that word is hard to write. So now it returns 6. So now this looks really simple, but it's kind of hard to understand. So we can visualize it by drawing it like this. So in the first layer, oops, let's go back. So it does integer 3, so 3, this equals, it checks if x is less or equal to 1. So this is greater than 1. 3 is greater than 1, so it returns 3 times 3 minus 1's factorial. So then it checks it again. 3 times 2. So 2 is 2 less or equal to 1? It is not. So it goes to the else again. So multiplied by 2 minus 1 factorial, which equals 1. So it goes 3 multiplied by 2 multiplied by 1. Let's make these multiplication signs to easier understand this. Multiply. So now we check at 1. 1 equals 1, so we could return 1, and then 1 times 2 times 3, and then this equals 6. And that is how we do an recursion. One thing to note with recursions is that there has to be a base value. If there is no base value, then it will keep on recursing every single time, and then it has no end. So make sure there is a base value. For example, in this one, the base value is when x equals 1. It comes in here and then returns 1. This is very important. Alright, so that is basically all we need to know for functions. Next, let's talk about structs. So structs is short for structures. Alright, heading 2. Data structures allow us to define custom data types that group related data elements together into a single object. Before you can use a data structure in your sketch, you need to define it. To define a data structure in the Arduino, let's say Arduino sketch, you can use the struct statement. Here is the generic format for declaration. The struct, and then a name. And then inside of here we have a list of variables. And then it ends with a variable name. Like this. So an example is structure sensor info. So this is information we get from sensors. And then inside of here we can write character array of date. So every single character of the date is set in an array. So 2 numbers for months, 2 numbers for date, and then 2 numbers for year, and then the slashes in between, +1, which is 9 of 9, and then we write the integer of, let's say, indoor temperature, indoor temp, and then an integer for outdoor temp. This is a lowercase I, and then we can say, like, we can create a variable name, whether it be the morning temperature or the noon temperatures or even evening temperatures. These are all, so we have 3 variables now, and each variable has this data structure of characters, integer, and then another integer. So character array of 9, and then an integer for the indoor temperature, and an integer for the outdoor temperature. Alright, so let's run this. There's not much to say about structures. I think this is basically it. We can run it. Struct. Can we maybe try to run this? Struct. Did I spell structures wrong here? Oh, wow, I'm so sorry. This is structure sensor info. Alright, and then here we can do, let's say, serial.println, or sorry, let's just do print. Oh, before we print out the things, we need to initialize the different variables. Let's say string copy. I think we talked about this in the string section. We can morning temps.date, and then we can copy, say, 08 August the 6th of 2024. So this copies every single of these characters into the array, and then the last one is for the ending character that we can't see. So this is the string copy, and then for morning temperatures dot indoor temperature, we can say, let's say 25, and then morning temperatures dot outdoor temp is, let's say, 30. Morning temperatures is 30. So let's first print out these before we run the noons and evening. So let's just do this to make sure we are running this on the right track and simple. Today's date is, and then we can write morning temperature dot date, and then print today's, or let's say the morning indoor temperature is, oh my god, serial.println morning temperatures dot indoor temp. Well, these has to be capital S, indoor temp, and then serial.print the morning outdoor temperature is, why is there like this, and then let's run it. Alright, what did I spell wrong? Morning temps. Alright. So now we can see today's date is August 6, 2024. The morning indoor temperature is 25, and the I forgot to write, and outdoor serial.println morning temps.outdoor temp. Oh, I forgot the semicolon, sorry. So now, today's date is August 6, 2024. The morning indoor temperature is 25, and the morning outdoor temperature is 30. So structures can help us visualize and make the code simpler. And for codes that have like a few hundred or thousand lines, having a structure for different variables would be really helpful. Alright, now for the homework. We didn't learn too much today, so let's just do a factorial. Find the factorial of 6 using a recursion function. So recursion is this. If we remember, we did the recursion of 3 from this whole thing. Alright, and this is the fourth lesson on Arduino C. Thank you for watching, and remember to do your homework.